Welcome to our class, and today we will study about sets, and these are the important things to remember, or important words or terms to remember. Okay, let us understand what sets are. And a set is defined as well-defined group of objects, a collection of objects, a collection of things. Okay, when we say well-defined here, it means that the given object or the given set of things, one can clearly determine whether the object belongs to a given set. Let's say, for example, number one, the set of positive numbers. Okay. So in this set of numbers, it is clearly described or well defined that the things that need to be on a given set are all positive numbers. Let's say set A 1, 2, 3, 4, 5, and so on. Okay, all the positive numbers starting from 1 and above are all positive numbers. We call this this is a set. And another example is the set of fruits. This is also an example of a set. Let's name that set as B, and in this set we only write the fruits. Say apple, what else? Banana, grape, and so on. And this set, it says fruits. You don't write there 5. You don't write vegetables. It says there, it's well defined that the only things that or objects in this set are all fruits, nothing else. And let's say letter B, the set of healthy people. Yeah. Right, this example is not not a set, not a set. Why not a set? Because when we say healthy, you cannot just tell anyone that is someone is healthy. They have to go under thorough examination in the hospital. Someone should examine you, or it's hardly you cannot just tell other people that they are healthy, but they should go to the hospital for general checkup. So I'd say that example number 3 is not a set. It's not well defined. Okay, and another is the set of famous artists. This is also not a set. Why? Because of this famous, no? Some artists are very, very famous to other people, but to some they are not. So this is not well defined. So we cannot say that. We cannot just put or list all the names here of people, because not all artists are famous. Okay, that is a set. It should be well defined. And we denote sets is denoted by a capital letter, like what I did here, A and B. Any capital letter, you can name a given set with any capital letter of the English alphabet, A, B, C, D. Let's say set A. The set of even numbers, 2, 4, 6, 8, 10, 12. There. We have these 3 dots, the ellipses. It tells us that there are more numbers after 12, and we call that infinite. Infinite set. Okay, if you see that 3 dots there, this set is infinite. Right, these 3 dots, the ellipses, is telling us that these numbers doesn't stop. There is no last number. But if we say set B, 1, 2, 3, 4, 5. Okay, the set of the first five positive numbers. Okay, this is a set. Now it is well defined. It says there first five positive numbers. Okay, nothing else. And this is finite set. Okay, letter B is a finite set. Why finite? Because there's no other number aside from those 5. 1, 2, 3, 4, 5, and there is no dot there, the ellipses. Okay, so that is a set. Alright, subset. What is a subset? Subset is a set of which all the elements are contained in another set. Let's use the Venn diagrams. Let me give you a set first. A, 1, 3, 5, 7, and B, we have 3 and 7. Yeah, it means that B or set B is a subset of A. Why? Because all the elements of B, 3, 7, are also elements of A. To put that in Venn diagram, A is occupying the larger area and B is the smaller area. A 1 3 1 3 7 and there 5. Okay, it looks like this now using the Venn diagram. Right, A here is occupying this whole area, and the elements of A is 1 3 5 7 there according to the given set, and B has 3 and 7. They're subset, no? B is a sub. That's why B is a subset. All the elements of B belongs also belong to set A. Okay, that is subset. A set inside a set. Okay, that's why you say subset. Submarine. The word there sub is underwater, in the water. Okay. That is subset. And what about universal set? Universal set. Universal set, the set of all objects under consideration. Okay. Yeah. The Venn diagram for the universal set is a square or rectangle or four-sided polygon. Okay. We name universal set as set U. It means universal set. Right. To understand this, let's say U set is 1 2 3 until 10. Okay. Right, we have used there the dot. It means the number goes until 10. This is not infinite now because there is a last number there. It's a finite set. So the elements of U or set U are all 1 2 3 4 5 6 7 8 9 10. Okay, this is one way to denote. If there is a pattern, you can use this symbol, but if there's none, you cannot use this. Alright, A, it's a set A, the set of even numbers less than 10. Set B, the set of odd numbers less than 10. 1 3 5 7 9. Okay, universal set. In universal set, it has all the elements, okay, under consideration there. And A is a subset of B, subset of U and B as well. Okay. Alright, the Venn diagram for this is this one. Why are they separated? Because A has no element that is common to set B. Okay, that is how we illustrate sets using the Venn diagram. Right, the elements here are 1 2 2 4 6 8 10, and here in set B 1 3 5 7 9. Okay, you see that? Okay, we will talk more about this the Venn diagram, how we illustrate sets using Venn diagram. Okay, so here is U set now. All the elements under consideration is right here. The elements that all belong to set U. That is universal set. Alright, null set. Right. Null set. There are two other terms for this. This is the usual terms that we use in the class. Empty set. We seldom use this null set and void set, but all these three, they mean the same thing. It's empty, no elements, zero elements at all. Okay, and this symbol is denoted by this, no? And this means empty set and empty set as well. Okay, two braces without element is an empty set. Has zero element. Okay, before that, now these objects in a set, we call them terms or elements. These objects now, okay, say elements. Okay, and we denote sets with capital letters, and the objects, or we call them all elements. Okay, next, cardinality of a set. Here, the cardinality of a set is the number of elements of any given set. Example, A 1 2 3, and say cardinality, how many elements are there in the set. How many? See, there are 3. N of A is 3. Okay, just count the number of elements in a given set, and they are the elements are separated by commas. Okay, another example, Alright, the elements of set B are empty set and the set of odd numbers. Okay, sets can be an element, just like this. Okay, a collection of sets. Okay, this is empty set, set of odd numbers. So we say that the number or the cardinality of set B is n of B. N stands for number, B the set. Okay, so n number now, so the answer here should be a number. How many sets are there? 1 2. Yeah, that is the cardinality of a given set. Alright, one more. before we go to Venn diagrams. Okay, there. So how many elements of set C? 1, 2, 3, 4, and 5. There. You say n of C is equal to 5. The number of elements of C is 5. 1, 2, 3, 4, 5. Okay, that is cardinality. Just count the number of elements in a given set. Okay. Alright, let me repeat. Sets can also be called elements, okay, because in here in set B, this is a collection of sets, set empty set, and here set of odd positive numbers. Okay, and each element is separated by a comma. Okay. And Venn diagrams. Okay, Venn diagrams are figures representing sets in the form of an enclosed regions. As I have said, first, what is this again? A rectangle. The set U. Yeah, using Venn diagrams. It says there are figures representing sets in the form of an enclosed region. Here, we always illustrate the U set as the four-sided polygon here. It can be a rectangle or a square. And the other sets, with we use circles, okay, in closed regions. There, A and set B, and these two sets are subsets of U. Okay, and the elements of A and B are all elements, can be elements of set U. Okay. Venn diagrams. Okay, a Venn diagram is widely used diagram style that shows the logical relation between sets, popularized by Venn. Okay, this diagram or illustration was popularized by Venn. Okay, let me give you some illustrations about Venn. A, B, and U. What means these two, A and B, has a common set A union B. That means that A and B here has a common element or elements. 1, 2, 3. Okay, that number 2 there is the common element to A and B. A 1, 2, B 2, 3. Okay, both of them, no, both A has 2 there and B as well. Okay, we call that the Venn diagram of these two sets overlap, no? But if they are separated there, no overlapping of the enclosed region of set A and set B, it means no has no common element. Yeah. Um, 1, 2, and then 3, 4. Okay, as you can see there, in set A has 1 and 2, and 1 and 2 you can see it on the set B and B as well. Okay, all the elements are completely different, so this area will not overlap the other. Okay, that is another way of illustrating Venn diagrams of the union of sets. And another one is that AB means both elements are A and B are the same. Let's say 1, 3, 5 B, 1, 5, 3, and so on, or something like this. Okay, both have the same number of elements. We say that A equal to B. Okay, and another, the one that I gave last year, no, it's not. Yeah, A, B. This is a subset of B is a subset of A. Yeah, it means that B is inside set A. All the elements of B are also elements of A. B is a subset of set A. Okay, set B. Remember now, we denote sets with capital letters. Okay, it means that A, 1, 2, 3 examples only. These are the elements of A, and to set B can be 2. Okay, there, all the elements of B can be seen, or yeah, it's also belong to set A. Right, I'd like to add more. Let's say 3. There, all elements of B are also elements of A. Okay, this is 2, 3, and 1. There, A, this big circle there, all the elements that you can see there are elements of A, 1, 2, 3, and set B only 2, 3. Understand? That is Venn diagram. No? Figures representing sets in the form of an enclosed region. Okay, those are the important terms that you need to remember about sets, and there are more, but into your level, these are all the important terms for you to remember. Okay, I'll see you again in our next part of our lesson about sets.